I'm really going to miss seeing you today. I've really enjoyed our last 2 lessons together. I hope that this finds you well and healthy and strong ahead of this lockdown that we're going to be experiencing. I'm thinking of you and your families, and I really hope that you'll be able to find some new and exciting things to do in the time that you can't go out, and I really hope that you can stay positive and make the most of it, because the one thing we do have control over is our attitudes. So I really hope you can make the most of it. Okay, so your parents may have told you how we're going to be doing things. We're going to be using an app called Google Classroom, and I'll be sending them information a little bit later about how you can join my classroom. And on that I'll be posting more regular updates. So rather than us doing chemistry only once every 2 weeks, we're going to start doing chemistry a little bit more regularly, but in smaller bite-sized chunks, because I think for us to try and just stare at a screen for 2 hours every 2 weeks, I think I'll put myself to sleep, let alone put you guys to sleep. So we're rather going to do smaller bite-sized chunks over time, and hopefully that'll keep you excited about chemistry, and so that when we do get back together again, that we can pick up where we left off and move forward and do some exciting physical experiments and get to see each other again. So what I'm going to do today is just really quickly try and pull together some of the things that we've spoken about over the last 2 lessons, as well as where we're going to be going in the next few lessons. And I'm not really going to call them lessons anymore, because they're not the full thing, but it's like little topics that will be making up the lesson. But I will be sending you everything in Google Classroom in order, so that you can do it at your own pace, in the order that I intend, and yeah, we'll all get to the same place in the end, so timing is not really an issue. Okay, I hope that all makes sense. So let's just quickly, if you have a page, and you can maybe make the summary with me, if you don't have time, you can always go back and play the video again. But I want you to have an A4 page, just a plain blank A4 page, and turn it sideways. Okay, so make sure that it's landscape like this, and we're just going to quickly do a summary, including all the words that we've done already. Okay, so the first thing that we're going to do is we're going to kind of, if you can imagine dividing your page in half and then in half again. If you want, you can even fold your page. And on this side, we're going to write here, we're going to say elements. Okay, so we're going to talk about, we've already used the words elements. Okay, that's kind of about half. And then in the next quarter, I'm going to write compounds. And what's the last one? Mixtures, right? Okay, elements, compounds, and mixtures. And those are the 3 different types of substances that we've spoken about so far. Now, I sort of mentioned this before, but something that I really just want to drive home is the idea about pure substances versus impure substances. Pure substances are only made up of one type of substance, so that is then elements and compounds. They are both types of pure substances, right? So let's change pen color here. So these 2 over here would be considered pure substances. Okay, whereas mixtures, because they're made up of a number of different things by definition, mixtures would be impure substances. And remember, the word impure doesn't always mean bad. It's not in the English sense of the word impure. It's just saying that it's only made up. It's made up of a number of different things. So, for example, drinking water that we drink would be considered a mixture, because it contains water, H2O, like we spoke about, as well as a bunch of ions. So like fluoride ions, there's some calcium, there's a bunch of different things in drinking water if you taste it. So by definition, it's actually a mixture, which means it's an impure substance. But that doesn't mean that it's bad for us to drink. In fact, like we chatted about in our last lesson, if you were to drink pure water, absolutely pure water as a compound, it would be very bad for you, because your body's not used to that. And it would lead to actually problems for your cells. Okay, so now I want us to talk, to bring some things together and talk about how elements can be divided, which is what we're going to be heading towards over the next little while. Elements can be divided into metals and non-metals. Okay, so we can either have our metals or we can have non-metals. Okay, and how that all works, sorry, we can miss that. How that all works is that on the periodic table, which we're going to be getting to know more and more about as time goes on, you have on the picture of the periodic table, you have the metals on the one side and the non-metals on the other side. I'm going to try and show you a picture of my periodic table. I'm not sure how great it's going to come up. I mean, this is a small one. But on the periodic table, you'll see that there's this little step here. Let me come a little bit closer. You can see that there's this little step going down the periodic table. That little step indicates that this side, which I've kind of colored in more blues, this side is the metals and this side is the non-metals, which is why on our little summary, I've written them on the left and on the right, because that's exactly how it is on the periodic table. So it's like you're going to have that little step going down the periodic table. The metals are on the left, the non-metals are on the right. And the thing that's different about them, the things about metals and non-metals that are different, we're going to look at over the coming few sessions, and so we'll get into that in a bit more detail. But I just wanted to give you an idea of kind of what they would look like. Okay, so if we're talking about our metals and our non-metals, it could be, remember like last time I used Raylan's little Linky toys, where we had, I don't know, what was it, the red flowers and the blue stars or something, just to kind of give you an idea of what elements and compounds and mixtures might look like. So I'm kind of going to go ahead with that, but I'm going to use red and green to show you the different colors of what I'm talking about. So an atom could, an atom of a metal, for instance, might be like this. I'm going to use stars for these. Okay. So that on its own would be an individual atom. Okay. Non-metals would be perhaps something like our flowers. Okay. So there's going to be our red flowers, like we had before. So each of those would be considered individual atoms. So let's add that onto our summary here. So that would be an atom and that would be an atom. So like that and that. Okay, so those are each atoms. I hope that you can see that. Sorry, it's not very clear. And then a compound would be if you now mix some of those together chemically, remember? Chemically bonded together in a fixed ratio. So it's a very, very specific thing to do. So if I have some of my stars, for instance, mixed in with some of those flowers, so they've been chemically bonded together, okay? If I pick up the one, I automatically get the other. They are not, we can't easily separate them, okay? So that would be considered a compound, and this would be considered, if I had to call this something, if I had to call one part of a compound something, I would call that a molecule. Okay, so that's going to be considered a molecule. And then a mixture would obviously be any combination of any of these. So I could have some flowers on their own. I could have some flowers bonded to stars, like that. I could have some stars on their own. You can pretty much have anything. Okay, and a mixture is just going to be, there's no fixed ratio, and things are not chemically bonded together. They're easy to separate, that sort of thing. Okay, one more thing I just want to mention, something else or another type that we could possibly get would be, for example, I'm just going to put it under the non-metals because that's where they would most likely occur. If I were to have something like this, where you have two of the same atom that have been chemically bonded together, and they only ever exist like that. Do you remember what we called those? We called those diatomic molecules. Okay, that means that they would only ever exist like that. So I'm going to just label it like that just so that you've got an idea. So this is going to be a di meaning two, and then atomic, so we're saying a two-atomed molecule. Okay, so it's saying that they're only ever on their own, that is how they exist. When they're bonded to something else, that's fine. They can bond to something else, absolutely. But they, when they're on their own, they have to be in pairs. Okay, so there you have it. There's a quick summary. And what you could maybe do is you could add on to your summary some of the definitions that we've done before. So you could add on the definitions that we had about an element, a compound, a mixture, and you can kind of flesh this out and make sure that you can visualize it all a little bit better. And then we'll be going into a little bit more detail. We'll be recapping exactly what atomic structure looks like. I'm going to give you a bit of a game to play with some how to set up an atom for some of the different elements. And then we'll go on to what are the differences between metals and non-metals and semi-metals or metalloids, because I'm pretty sure some of you are like, wait, what about metalloids? So metalloids would be somewhere in the middle, right? They are things that very often look like metals but act like non-metals, or vice versa. So we'll chat about those as well. And then we'll bring it all together on the periodic table, which is going to be really, really cool. So I hope that this helps a little bit, just to help you to see where we're going, where we've come from. And just sending lots of love and lots of blessings and high fives, and virtual ones, not physical ones. And I wish you guys all the best, and I will be in touch with you more regularly and looking forward to it. Okay, cheers guys, have a good day.